Thanks a lot for this conference. It is super cool. And okay, so I will start with time for photo. So, wait, doesn't work. Okay, so my talk is going to be super short because Sylvie Granon told already about what I've done with this classification. So I was planning to speak about chunks 3, but as good as something super great, so I don't need to. And Elodie spoiled everything about the new vocalization that we found. John-Pei and Bernard spoke about this real-time loop, and I was thinking about this active beamforming, but there is no use. And I'm expecting that the forecomer are going to speak about the classification, and also Deep Squeak is going to nail it. So thanks a lot. Do you have any questions? Okay, so maybe if you want something. So this is live mouse tracker. Well, you know it. The idea is that here on the left you have the live tracking of the animals, and on the right you have the behavior of the animals, and it's just like in the game, you know, who is doing what to the other thanks to the color and so on. So this is basically what we retrieve as a behavior, and you can create your own behavior. So now we have fights, works, things like that are interesting, but we saw it last year. So I need to say it again, but so we have this individual event, we have the dyadic state event where you have two animals, and we have the contact nose, contact nose each other. And the one that I really like now is this contact side by side in opposite way, because it's always popping in the experiments, and I think it's interesting. And then you have also the different approach, the different breaking compact, and this follow behavior that is always discussed because we never really agree on the labeling that is done with this. And also when you have more animals, and for the groups of 4, the group of 3 of the breaking also. And now we are, here's an example with a 9 animal, I guess, and it's not a dead animal that is in the middle, it's just to show some, it's a crocodile, it's a toy. And the idea is to put something that is looking like the mouse to trick the tracker to see if it's working or not. And so the idea here is to show that we are able to put more animal, and I will show that we can put even more animals than this. So, you know, like mouse tracker, it is, well, everything gets out from the software, and then you need to process a database to get all the different behavior. But some people like Nicolas Torquet has created this kind of software where you can see here the temperature, the humidity along your experiment and so on. And this is all made through a very nice website. So I'm very grateful to him to have created this. And here there's even a quality control to say, okay, you're missing frames, or your temperature was not good and so on. So it's really a super good assistant for this. And thanks to Metris, now I know that MEMS are sensitive to humidity. And this is something that is measured in LMT with a device that is on the site, and you can have an idea of this. So this is really for people that don't want to mess with the analysis. And it also allows to store everything in a specific location on the server in your lab. So a very nice initiative. And I know that 2 other initiatives like that are going to pop up in the next year. Okay, so the diversity of vocalization is super huge. And well, I was surprised yesterday by watching everything on the rats, because when we were watching the one from the mice, I think that we have maybe more variability. It's open to debate. And so from what I can see is that this kind of classification that we have on the left here, so the flat, the down and up, and U shape. Well, in fact, when we are dealing with our vocalization, so the animals are freely moving during 3 days. So they vocalize whenever they want, but they are not stimulated by something specific. We can sort everything within the complex category, and you can just forget about all the others. So maybe there is a little problem about this. So somehow, a lot of people here are doing it manually. And well, now I do understand, because I was bringing all the classification tools and so on. So this is the software that Elodie spoiled also yesterday. So we have automatically all the USV that are in this page, and the idea is that you can click on it to very fast to sort all your, classify yourself for your vocalization. And the idea was to make it blind. So you do it like that, so you don't see the video at the same time. And then you switch to the video view and you are able to see what is the context of the vocalization that you selected. So here it will come, but the idea is that the animal was just jumping on the wall and it was scraping the wall. So in fact, it's not a vocalization, and it's cool to have this synchronization to be sure about this. Yeah, you see now. So the film is going to loop over around the vocalization, and then you can switch to the next one and so on. So we find it funny, but you still have to, you know, to press the button to see the other one. So I was thinking about something else. It's like an auto editing of all your experiments so that you have a short film that is created with the vocalization you want. So the idea is that you have the frog voc, it is the name that Benoit gave to it because it has the shape of the eye of the frog. So it is one of the vocalization that he likes. I mean, when he was classifying, he thought, okay, that one might be interesting. So he was just selecting it. And then you have the auto edit. So this is produced automatically. You see the vocalization on the bottom right, and on the top left, there is a little signal telling you it is at that very moment that you had the USB that has been emitted. And this thing is going to jump. So maybe it was 10 minutes later, I don't know. But you have this little short film within the 3 days of your experiments, and you can also extend it to all your experiments that you have. So, well, you saw that this frog one, maybe some kind of mounting, like trying attempt to mount or something. So you have this mounting voc that you were speaking about, Elodie, yesterday. So it gives this shortcut, this auto edit video where you actually see that the animal is doing this. So those are 2 females. And we have that one that I like. It is what we call the double flag voc. So we try to find something. So here you can see on the right, the shape of the vocalization here. So it's kind of an upward, but there is an elbow here, and then it prolongates. So that's, sometimes you have a second part here of the vocalization. And so you're going to see what is happening during this vocalization. And well, so the spoiler is that the animal is stand up and maybe sniffing. So we try to work with people to know if they are actually sniffing, if it is related to that specific behavior. But we are very happy to have this new one. And the idea with this software is then that, I'm sorry, it's super ugly, but I redone everything this night because I was spoiled by everything yesterday. So this is the kind of graph that you can have to see with the vocalization that you selected. How are they represented through the events, the behavioral events that you have within the cage? And well, so it is just one click, and this is actually this is real time. So you can just select your vocalization and see this evolving. But I don't know if it is good or not, because you might be willing to you know, to increase some barriers. So maybe there is a bias. Maybe we should not do this. Okay, so those are another kind of rat or mice, I don't remember. And what is great with those mice here is that they are living in this super big area. So I've been visiting this. It is a primatology center of Rousset in France. And I find it super inspiring for us because yesterday, Sylvie, you said that your female, they were vocalizing much more when they are in a rich environment. And well, I believe this is super exciting to do this. So for this thing here, the animals can come into those boxes here, and they have a screen, and they play with a program that is on the screen, and then they get a reward, and they're identified because they have a necklace that you can see here, just like if you were in a gang. And so the idea is to do the same with mice. So you have, let's say, 20 mice, but there's no real limitation on this. And then you want the animals to access 2 different tests. And well, you have an RFID chip on the animals so that you can get the identity. So to do this, it's a bit complicated because you need a lot of gates. And this is what I tried to enable for the last year. So somebody is coming to me with that kind of map. And what I'm proposing is that you just use a laser cut printer and you obtain this thing here. So it was the beginning of the story. So it is in my room. I hope you like it. And to do this, you also need a gate. That is this part here. And the gate actually costs a lot if you take it from a company. And here, so this gate is able to weight the animal to get their identity, and it will never hurt the animals. And I mean, the doors are slipping from down. Well, I had 41 versions of this gate to obtain something that I liked. And this animal here is passing through this gate for the first time. It is super slow. Everything is super slow. And if you look at the gates that are existing, they are quite fast because they are afraid that the animal is going to escape or everything is fast. And here the idea is that the gate is transparent to your experiment so that you don't need to test how animals are afraid of your gate, are afraid to get pinched by the tail or whatever. The idea is that you just don't consider the gate. And you can, I mean, there is a program that is already given with this, but what you can do is to program and interfere in whatever the gate is doing. So if you want this gate to open and then to switch on the light in your bathroom at home, it is possible because there is no limit in the connection of this. And here the animals are discovering the gates for the first time. So you don't have habituation, you don't need to have habituation time. So it does exist for rats. So it's just scaled up twice. And I like that one because people told me, okay, it's cool that you have gates, it's cool that you have those boxes, but we need the lever, we need the feeding, we need all the other things. So I told them, okay, let's go. So everything you see here, all the apparatus, they are built from just a laser cutter and a few pieces of electronics, and everything is based on Arduino. It's super simple to build. And here you see a number of rats that are trying the lever for the first time. And well, this is working super well. I was very excited with this. So we thought about doing something like an automated synchronous versus social test, where you put animal in the gray area, and then they have to work with the feds that are those device here. So I cannot point, I need to point here. So the animal just no spoke in this, and they're able to access the different area, and you have different phases. And well, the guy who created the Fed, I met him last week, is a genius. And what he says that you put the Fed within a cage, and instead of having your animal and you put it to the operant wall for 1 hour a day during 1 month, you have the same results in one night because you let the apparatus within the cage. I thought that it was not possible because I thought the animal needs to sleep and so on, but it's not the case. And in here, we observe the same rate of learning, and we put the animal for 2 days in this system, and here you see the different phase for the different animals. And when you have this very big red bar, it means that it's taking a very long time, and it is for our chunk 3. And for the other, you see that it's quite fast, and you can really I mean, the system is going to switch from phase to phase automatically. So basically you put your animal and you come back the day after or 2 days after, and you're done. So there is nothing about USB here, so at some point you will get upset. But the idea is that, is it possible to use this kind of fast learning environment for the and to put playback device in this, so that, for instance, you can learn to the animal, and because you can create synthetic vocalization, and you know which animal is coming, so you can train the animal to see if he is able to discern between different kind of vocalization. So I'm bringing you this kind of device so that you can unleash your ideas about this. And so, well, I would be very excited to see what you can do with this. And here it's what we want to do as a proof of concept for our concern, that we have on the left a collaboration task here, where the animal is asked to sequentially press a lever, and there is an OLED screen that is on in the cage, and you have here water with sugar. And at the same time on the right, you have an altruism task, and in the very middle, you have the live mouse tracker. So the idea is that you are able to see what the animal are doing, how they perform in the test, who is coming, who is going to collaborate with whom, so you have matrices. And you also have the impact on the social contact behavior that the animals are going to have together. And if you run it fast, you can see actually you know, this GUI here where you see the gates that are moving and so on. So we try to put a lot of monitoring in the experiment. And this software that you see here is also open. So it means that if you want to create one, you say, I want a gate, you have a gate, you connect it to 3 COM ports and you have it. And all the different boxes and so on, the program for the fed, the program from the lever, and you have real-time feedback of all your experiments. And you can even intervene in it if something if something goes wrong, like what will be, yeah, you have a pump that is not working anymore, or, so you can reprime everything if you want. And you see the different phases where you're. Okay, so that's the live mouse tracker blocks. So did you? Yeah, I did. So do we have still time, or am I gonna, because I really don't want to overtake Pavel. It's okay, I can continue. So, okay, very fast. I was thinking of something is that I'm spending a lot of time watching you working. Okay, so I'm behind your shoulder, sometimes strange. And what I thought that it would be cool to bring you a new tool. So you tell me if it's not interesting or not, and it's not done, it's ongoing work. So it's kind of live mouse tracker Shazam. So you know Shazam, it's people tell me I'm old because I know that. It's you have your phone, you are listening for music and you put it and then you have the music, but there is a lot of different algorithms that are doing this. So I was thinking that it would be cool to do this for mice, but in another way, so that you can pick a sequence within your spectrogram of something you like, and then the system is automatically going to search for the same thing in all the database that you have. But the idea is to make it in seconds or less, or to do something that is, in French, we call it the memoage. It's just like you say, and the thing is going to find the music. So it is much more difficult. And for us, it looks like the drawing that you have here. So if you draw a frog in here, and then you tell the system, well, in fact, I'm absolutely not sure of the orientation of the shape. I don't know if the frequency is good or not. So you give relaxation to the system. And then the system is going to seek for equivalent of your drawing, taking in consideration the elbow that you're going to put and so on. And I think it's a different approach from the one of machine learning. It's a bit different. And then the idea is that when you're doing this, you have a live view of everything that is like what you are seeking for. So maybe it's well, so it would depend on your drawing skill. And you have also this matrix here showing the link between the behavior and your drawing. So I could explain it, but I think we are late and it's boring. So just the thing I can tell you is that in Shazam, in fact, the system is only watching the future because it doesn't need the context of what has been said before. And for vocalization, it's a bit different. So we need to consider both, but it's very technical, so it's not very interesting. So now an advertisement. Yeah, this thing is not interesting too. And that's the end of my talk. So thanks a lot. Been fast.
Yeah, that was really fun. I thought you were gonna beat me in the shortness of the speech,
Yeah.
but you didn't. That was intense. Great. So do you have a question? Do you have a question?
Oh, you get
Yeah.
commercial. I don't manage it. Yeah, so the question is, how do I manage overlapping call? So I don't. Yeah, but I mean, I'm super excited by what I've saw here today, this morning. Yeah, and I think this is definitely something that we need to implement. And yeah, I want to have this thing in live mouse tracker with the emission of the vocalization, of course. And then you can discard who is doing this. But well, we don't have so much overlap, I would say. Yeah. Another challenge is that we're open to different fields. So you can have one like mouse trackers, some blocks, and another one. And we want to, I mean, we can keep the identity within all the big environment, but we want to also grab the USB from those different environments. And so there's this closed loop to we can know from which microphone is coming the USB if there are very different environments, but it's not as good as what they've done.
Okay, so we have a question. Tasha, could you pass the mic?
I'm just curious, are your dates also aligned with
Yeah.
so that you know whether there's one or two animals and you can decide when to open?
Yeah, so the decision to know if there is one or two anymore is made on the scale. So it works with rats and with jailbreed too. And with jailbreed, it's funny because they can hang on the door, so they are able to hit the scale somehow. So it's funny. But well, for most of the yeah, so it's based on the weight of the animal. And then on the list you have an RFID. And this RFID, you know that you cannot activate them all because you have other stuff for everywhere. So everything is communicating to say, okay, I need to read an animal. Please stop this, stop this, stop this, stop this for till 2 seconds. And then everything is synchronized that way so that the gate can read the animal. No, it's because it's a very old one. Because what you saw here was the test experiment, and in that case we use the old animals so that we don't need to waste very young animals to do this. Yeah, no, there is no marking. There are most of the times they are litter mate, and they are all the same age. They weigh about all the same weight at the very beginning of the experiment, and then it moves. Because they will fight, they will, some things will happen.